Hi everyone and welcome back. As a quick recap, in the previous video we went through a quick historical background on capsule networks and also examined the convolutional neural networks to see why capsule networks can be necessary or the possible next step within artificial intelligence in the pursuit of creating more powerful and beneficial algorithms. We can also see a piece of the architecture here along with the MNIST dataset information, but we're going to dive further into the architecture in a moment. So with that being said, we can now get started on examining what exactly is a capsule network, or even more specific, what are capsules? And capsules really introduce a new building block for deep learning. And for this, we can actually go and examine the paper published by Hinton and his colleagues to examine the abstract, and it does a great job of summarizing the key points that we can see with the following. If we go to the dynamic routing paper and we examine the abstract, we can see the following useful information. And the abstract states that a capsule is a group of neurons whose activity vector represents the instantiation parameters of a specific type of entity, such as an object or an object part. We use the length of the activity vector to represent the probability that the entity exists in its orientation to represent the instantiation parameters. Active capsules at one level make predictions via transformation matrices for the instantiation parameters of higher level capsules. When multiple predictions agree, a higher level capsule becomes active. We show that a discriminatively trained multi-layer capsule system achieves state-of-the-art performance on the MNIST dataset and is considerably better than a convolutional neural net at recognizing highly overlapping digits. To achieve these results, we use an iterative routing by agreement mechanism. A lower level capsule prefers to send its output to higher level capsules whose activity vector have a big scalar product with the prediction coming from the lower level capsule. I apologize for reading through that text, but this abstract really does do a great job of summarizing up, one, the dynamic routing between capsules, and two, the information related to the capsule network. And from this information, a really big takeaway is that we can see here a capsule is a group of neurons whose activity vector represents the instantiation parameters of a specific type of entity, such as an object or an object part. Now let's jump back and examine some of the architecture published in this paper. In this figure from the dynamic routing between capsules, we have a simple CapsNet with 3 layers. Now, the architecture is shallow with only 2 convolutional layers and 1 fully connected layer. Conv1 has a 256 9x9 convolutional kernels, we have here, with a stride of 1 ReLU activation. This layer converts pixel intensities to the activities of local feature detectors that are then used as inputs to the primary capsules. The primary capsules are the lowest level of multidimensional entities, and from an inverse graphic perspective, activating the primary capsules corresponds to inverting the rendering process. The second layer is a convolutional capsule layer with 32 channels of convolutional 8D capsules. That contains 8 convolutional units. And each primary capsule output sees the outputs of all 256 by 81 Conv1 units. And if we move on to the decoder, and remember, this was pertaining to the MNIST data. This is the representation of the structure to reconstruct a digit from the digit caps layer representation that we have here in the following. We have our ReLUs and sigmoid as well. The Euclidean distance is mentioned within the architecture published in the paper, that between the image and the output of the sigmoid layer is minimalized during training, and you also use the true label as reconstruction target during training. But let's summarize it and then try to at least condense it into some more digestible terms for an overview of just the general sense of the CapsNet network. So CapsNet is composed of capsules rather than neurons as a big takeaway. And with that being said, a capsule is a small group of neurons that learns to detect a particular object within a given region of the image and outputs a vector whose length represents the estimated probability that the object is present and whose orientation encodes the object's pose parameters. Similar to a regular neural network, CapsNet is organized in multiple layers, but in the CapsNet capsules, in the lowest layer are called primary capsules, and the capsules in the higher layers are called routing capsules, detect larger and more complex objects. And we also have the following procedure here from the routing algorithm and the paper that was published. If you want to explore it further in the meantime, that will be great. It's always highly recommended to go through that published paper and view the context for further information related to the CapSet network. But for now, let's wrap it up. And as always, if you have any questions, please feel free to share them. I hope that this information has helped started to give you an idea of what capsule networks are. Please subscribe to the Super Data Science channel to keep up to date within the industry. It's also a great way to learn some new things, and I will see you in the next video.